Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be continuing on from our previous video in the Evolution of the Solar System series. So if you remember the previous one, we did future events that would change the solar system forever, remastered edition. Yeah, you guys really enjoyed that. A massive thank you for all of the positive feedback on that. It's absolutely amazing. And also a massive thank you for 20,000 subscribers. As yet, we've done it. We have hit the big 20,000 mark, so I cannot thank you guys all enough for that. And if you've got any ideas for what we could do for a 20,000 special, maybe like a live Q&A or something like that, let me know what you think down below in the comments, because that could be quite cool, and hopefully I can get that filmed at one of the weekends, because that's when I film now. So I don't film any videos in the week, I do them all at the weekends. So apologies if it takes me a while to respond sometimes, because I'm usually most active at the weekends now. But with that all said and done, we'll move on to the video itself today. So we're continuing on from the future events like we did last video, but now we're going to be focusing on the sun a lot more today. So we've sort of evolved the solar system to a sort of future situation where Triton is now destroyed by Neptune, Saturn's rings have vanished, the moon has broken away from Earth. Apparently some of you guys gave us some useful info in the comments. Apparently it would take 2 billion years for the moon to eventually break away like this. So yeah, we'll say we're like in the year 2 billion now, but we haven't changed the sun's properties yet. And also, poor old Phobos broke away from Mars, but one thing around the Mars system as well, obviously it had its rings, but then they obviously all broke, they obviously disappeared after a long period of time as well. So apparently, from what one of you guys was saying in the comments, I don't know, remember this video is all speculation, no facts here, this is all just for a bit of fun as well, but apparently Deimos here, apparently this may have the similar fate to the moon, where eventually it's just going to fade away from Mars. So like Phobos went towards Mars, apparently this one may just break away from Mars completely. So what we're going to do is just going to extend the orbit out until it breaks away. Then it'll just be a free asteroid sitting roughly in the Mars asteroid belt area. So let's see, it's breaking away. I think the sun's probably going to grab it fairly shortly here. I mean, it's taken quite a big 2 months orbit now. Right, come on, you're going to break away eventually, Deimos? Come on, you know you want to. Just a little further. It's taken over a year orbit around Mars now. That's really crazy. But remember, Mars is still the closest object for quite a while. We're nowhere near the Earth or Moon area yet. So there you go. Now it breaks away roughly there. So if we just lower it down again. So it would roughly break away around this area here. So let's just slowly click that. Try and get it in like the sort of perfect area where it would break away from Mars. So we can see 1.2 years. So it's taking, there's a pretty big distance around Mars. So okay, so it'd break around somewhere here. That's where it'd break away from Mars. So can you still see Mars is the question I want to know. So where are we? So if we just turn all that off. Is Mars anywhere visible? Labels on. Where exactly is the old red planet? Mars? No? See all the other planets nearby. Where is Mars? Mars? Where'd you go? Okay, so Mars is up there. So yeah, you can see it. So it's a very far sort of distance away. We can actually what we'll do is we'll quickly land on this object as well and have a little look in the night sky. So whereabouts? Can you see Mars? Whereabouts are we, Mars? There you go. So you can see it roughly over there. If we turn off all the labels and stuff. Yeah, so that's quite a far distance if you think about it. So Mars off in the distance now. Phobos has gone. Deimos has now broken away from Mars, like the moon broke away from Earth. But probably like the moon, it's probably going to take quite a while for that to happen. So now Phobos will just be a free asteroid in the inner solar system, just to chill out and eventually end up who knows where, honestly. So we'll go ahead and give that a save, just so we've got that all done. But now, on to probably the moment some of you have been waiting for. The sun itself. So what we're going to do with the sun, we're going to sort of go up in sort of 0.10% of luminosity on the sun, but I believe we can also change the age stat here. So for instance, if I haven't actually really used this stat before, but I think if we press this button, it should start to change the luminosity of the sun. So if I put it to 6 and then 7 G years, does that change anything? No? 8? So this stat, I think, is a little broken, because it did, at one point, it did actually change the stats of the sun. So I'll just put it back down to 6. So we'll have to do it manually. But what we're going to do, simply, is it's going to be a bit of radius and luminosity. Well, luminosity is the main thing we're going to be focusing on here. So I'm not exactly sure how luminous it's going to get before it turns to a red giant. But what we'll do is we'll just do sort of luminosity. We'll do it in sort of we'll do it in about 10% of sun every time we do it. So we'll go 1.1 luminosity of sun. So that's obviously going to boost it up. Never mind the mass of the sun. That is going to be quite nice. So I'm just going to lock that back to 1, and we're just going to press the lock buttons. We don't have to deal with that for the time being. And then yeah, 1.1. I guess we'll do 1.15. Why not? So there we go. And you can see the radius has got slightly larger. So we're now stepped into the future a bit. The sun is now slightly brighter. So, for instance, here it is. So, if we compare it to what it was, that's the luminosity present day. And then we go 1.15. So, now the luminosity of the sun's got a little brighter. So, for instance, Venus and Earth are probably the two key objects we're going to want to pay attention to here. So, what we can do, we should be able to just press that. So, that's what we've got. So, we've got Venus temperature. And then the same with Earth. And I guess we can probably throw Mars in there as well. So, we've got Earth. And then Mars, because we're going to be focusing on the inner planets for the time being, because we do still have all of the outer gas giant moons in this simulation, but the sun's going to be a little bright. We're going to need the sun to be a little brighter before that starts to play into the game here. So we're going to click play. We need to speed up time a bit. Remember the moon as well. The moon is now a free planet. Debatable. The moon is now a free object in the inner solar system just chilling. So that's in a similar orbit to Earth. But we want to pay attention to the Venus and Earth temperatures mainly. So we can see Earth. Remember Earth started to flood in the last video because obviously all the ice is now melted. But eventually once it starts getting hotter again, that water could start to evaporate. It looks like some of the surface has flooded even more than when we left it in the last video. So that kind of plays quite well actually. But we'll have to just run this for a bit, see where we end up before we start to increase the sun stat again. But I think Venus as well is we're probably going to see quite an increase on Venus. So how are we doing at Venus? Venus is currently minus 50. I don't know why that is. It should be around 450 degrees right now. So I don't know what's going on with Venus there. What's that all about? How much atmosphere pressure have we got? Maybe we'll have to spawn in the regular Venus to make it work. How are we doing? So it's 85. It should be at 91 atmosphere pressure. I don't know what that's all about. So, okay, so yeah, I think we'll have to replace it with a regular Venus. I don't know why that's that should be a lot hotter, as we all know. So let's go ahead and just replace that completely, just with the bog standard Venus. That's fine. I mean, I know it doesn't look as interesting, but yeah, we'll just have to roll with it. But what we can do is we can always get rid of the make the atmosphere look a little more how it should. So we'll just go somewhere like that, I guess. I mean, we're not going for a perfect sort of build here, but yeah, something like that. Click play. Okay, so that Venus should already be. That temperature should in theory be increasing now because we've boosted the sun a bit. So let's quickly go back to surface, get our temperature for Venus there. Okay, so now we can pay attention to that. So how are we doing on all the other planets? So we can see Earth is now into the 21 area here. So that's interesting. So how are we doing on Earth? So that in theory could start. So we can see average temperature is now warming up. So that water is going to start disappearing eventually. So we're going to have to keep an eye on, be ready to evacuate Earth at this point, because I mean that's starting to get a little more nasty. How's Venus doing? So we can see obviously Venus is almost a tidally locked planet. I mean, but it rotates slower than it orbits the star. So yeah, that is quite a weird way of Venus. So 466 degrees, and it's getting fairly warm because even in the colder areas are still in the high 400s. So not much going on there. Mars is still in the minus 50s. Not too much action over there. What about the moon? How's the moon doing? I'm guessing the moon would eventually turn into a Mercury-like object, just being a hot rock. Obviously, not much going on. But we can see there, it's still sitting in the minus area, so the sun's luminosity still hasn't fully reached it. But if we look back at Earth now, 32 degrees. Whoa, right, so that's getting a lot hotter. So if we just slow it down, turn off the zone quickly. So let's just lower that down. So, for instance, I think maybe at this point the water would start to maybe retreat a bit. So what we can do, I always forget where that button is. It's on surface, isn't it? Here we go. So sea level. I think that would start to. Oh no, hang on. We want to lower that. So I think that would probably start to perish a bit. So what we're going to do is we're going to just slowly lower it. So it's going to go past the present day, but now we're actually going to start to see some of the water is now starting to disappear forever. So how are we looking on Earth now? So if we speed it up, obviously the sea level is now drained, starting to lose some of that water, is starting to evaporate. The atmosphere is going to start getting a little more thicker as well, possibly. The ATM pressure could change. We're not going to do that for the time being, but we're going to maybe we'll sort of roll with something like this now, so we can see the whole British Channel, for instance, has actually disappeared. So we'll have it like that for the time being. I think something like that, a fairly accurate representation. Obviously, remember, this is all speculation. It's just me having fun with the game. It's not facts. If you think it's different, that is fine. Let me know your thoughts and opinions down below on how you think it could look, because we're always interested to hear your thoughts on those. So, and now let's speed it up a bit, and let's see where we go from there. So, let's go ahead and do that. Now let it roll. So, is this where the Earth is going to roughly sit? 31, 32 degrees, 33. Okay, so I think we've roughly hit the maximum point for Earth now. Obviously, Venus How are we doing? So 1.15 on the sun still. Venus is 470 degrees. So we can see some... Venus is still sort of working itself out there. Okay, so interesting stuff there. So what we're going to do now is, I can see the Earth is still warming up. What we're going to do is, we're going to travel probably another billion years, another few billion, I'm not exactly sure with the time representation. We're going to go to 1.3 now. So we've doubled that 15 up to a 30. Radius is still bigger. Obviously, the luminosities, or the mass is still the same for the time being, because we're still, the sun is still in theory burning its hydrogen fuel at the moment. But now we can see the Earth hitting the 40-degree mark. So I think that blue atmosphere may start to get a little more grey, a little more cloudy, starting to turn more of a Venus-like sort of appearance. We can see maybe more cloudy, more greyed out. We're getting more water vapor sort of sitting in the atmosphere now. So I think that blue would eventually possibly turn white. I mean, again, speculation. I'm just trying to make it look cool as well. So maybe it would start getting more cloudier. And obviously, now we're hitting the 40 mark. I think that water, apart from the sea levels, I think the water on the overall planet may start to perish a bit. So if we click that a couple times, how does it look now? Don't know why there's some snow on there. I'm not really sure. So we can see Australia not looking good over there. We can see, obviously, the Indian Ocean down here. That's not looking good. We can see Madagascar there near Africa. How we're looking in the Mediterranean is cut off from the Atlantic Ocean. Obviously, the British Channel will be completely gone at this point. Into the America area. Gulf of Mexico is now cut off from the Atlantic and Pacific Ocean. So, pretty crazy stuff there. Obviously, the Amazon rainforest in Brazil here. That's obviously all going to be dried up now. So, more's being lost on Earth as time progresses here. Humanity, I don't know if the lights... I mean, we can keep the city lights on until they naturally disappear, but we'll keep them on for the time being. I'm not exactly sure if habitable. So, the game still thinks it's habitable, so we'll leave them there for the time being, but I'm not exactly sure that's going to be doing that much longer. How's Venus doing? So, we're in 473 degrees. Obviously, we're going to need to increase it now since we've just played with the sun, so we need to sort of let the simulation start to adapt to this. So, there we are. Outer solar system, I mean, we haven't really paid much attention yet. I think the first object we are going to want to pay attention to in the outer solar system would be Europa, around Jupiter here. But as we can see, I don't think we're going to be seeing this warm up for quite a while yet. Minus 157, I mean, it's not changing. The sun is just still nowhere near bright enough, luminous enough to affect any of the outer solar system yet. So it's still the inner solar system where we're going to want to be keeping our eyes. So let's just keep it running and see where we're going. So how's Mars doing? So Mars, minus 38, 37. So Mars is still sort of working itself out. I mean, obviously, further distance out, we can see Deimos is still orbiting behind Mars there as well, which is pretty cool. The moon, how's the moon doing? 4 degrees Celsius now, so we can see the moon is now into the positive temperatures. So that once the sun expands more, Mars will start to reach that area as well. So that'd be quite cool to see. Look at poor old Earth now. We're almost at 50 now. So that water probably will start to disappear without me having to manually alter it. So how are we looking here? Oh, dearie me, right. So I think at this point, maybe, no, we'll play with the sun a little more before I start messing with Earth again. So I'm going to buff it up. So I think the next buff up, so we'll go 1.3. How about we go to 1.6 maybe? So we can see the luminosity is getting bigger. The radius of the sun is getting bigger as well. Click play again. How are we doing? Okay. So we can see Venus and Earth are probably going to start really suffering from this now. So let's keep it going. Venus 488. So it's probably going to get to the 500. We see Earth is almost at 60 now. So that's not looking good. And what we're going to do is, I think there's more of it dried up. I mean, I can't really tell there. But I think what I am going to do, we can see America. Yeah, not looking good. So we're going to replace. Now, I made a special object for this. So I've actually made 2 variations of Earth that I want to include in this video. So if I just search Earth up. So it's this object here. So Wally Earth. This is an old modded object, which I've sort of altered a bit for this video. So we're going to spawn that in. So this is Wally Earth 2. So as we can see here, you can see the atmosphere is obviously the one thing we are paying attention to here. So the atmosphere, the water's evaporated. The atmosphere's got a lot thicker, more Venus-like. So that's the sort of, that's what we're sort of going for on this. So click play. Obviously, this Earth is going to, obviously, it's got the normal stats of Earth. I think there's actually still some water going on it. I think it's an old modded object, so obviously the surface not looking how it should be. But, I mean, yeah, that water, I think at this point we can fairly agree that that's not going to be around much longer, so we'll just go ahead and remove it. Obviously, we need to name it Earth again, but now Earth is sort of transforming into a Venus-like object, so a very thick atmosphere, trapping in heat. Greenhouse effect, in theory, would be rising. So if we go down to surface down here. So where are we? So we've almost caught up the moon again. Look at that. Right, where are we? So albedo. Maybe it's reflecting more light, but I think the pressure itself, ATM, let's go to 1.5. I think that's going to trap in a lot more heat now. We'll add Earth back to the list down here. That's not the one. I want the temperature one, please. Come on. Can we get... There we go. All right, so let's just go ahead and remove the ones we don't need. So Earth temperature, water, we don't care about. Don't need any of that. Don't need this one either. Get rid of that. Okay, so we've got Mars, Earth, and Venus. Mars is now at 20 degrees. We can see increase there. Earth, almost 60, coming up, almost getting to the 70 area soon. I've also changed the trail of Earth, so we can see no more blue planet in the inner solar system. So it's looking a lot more hot, almost. I mean, yeah, no more nice blue trail. Obviously, Venus is already like that as well. So you can see Earth and Venus are starting to look more alike, like the sister planets they in theory are. So poor old Earth not looking good. Outer solar system, I don't think we need to... I still don't think we need to really pay attention here yet. So, yeah, Jupiter's still sitting at minus 140. Mars is getting closer and closer to that positive temperature. So this is where we could start to see Mars start to warm up. I don't know why there's loads of ice on it. Maybe the sun's riled up all the ice and it wants to start melting. I don't know, but we'll leave that for the time being. So, sun, again, we're going to start to see a change. So we're going to go from maybe... What are we thinking? 1.9 luminosity of sun. How about that? So that's really going to upset the inner solar system now, I think. So we can see the zone. Yeah, the blue area is almost getting closer to Jupiter. The whole inner solar system, the asteroid belt area, that is now in the sun's blue zone. We can see Mars is almost at minus 8. I think minus 7 it's hitting there. Venus is at 530, 540 and increasing. So we can probably start to see at this atmosphere. It may start to sort of disappear as we see under the surface. We can see, yeah, that Venus is getting a lot hotter under there. So, right, okay. Let's keep it rolling for a bit. Let's just let it run. Just see how we end up. So, it's still increasing slowly but surely. It's going to take, obviously, some time before they warm up. Mars is now, if we look at Mars again, where are we? Mars. That is very, very close. So, the hottest part of Mars is so close to hitting that 0 degree mark. So, good stuff there. We can see it's almost there. It's doing it. We're getting close. Earth is in the 70 degree area now, so we can see poor old Earth. Yeah, you're not looking good too more now. Look at that. Oh, dearie me. So, not good there. I don't need density locked. Why is that like that? Okay, so 560 on Venus. Let's have a look at Venus again. Yeah, we can start to see Venus is starting to glow hot now. That you can, yeah, not looking good. So the hottest planet, definitely living up to its name now. That is getting a lot hotter. 560. We could probably see 600 in the next sort of jump we do with the sun. So I think we're going to have to do it now. So sun. So for instance, 1.9. How about we go to 2.6? A bigger boost again. That zone, you know, getting closer. Maybe we can do this actually. So we can see the radius is getting bigger, but as we observe as well, the Jupiter area is almost in that blue zone. So not looking good. We can see Mars. It's in the 30 degrees, so I'm actually going to lower that again, because I want to actually have a little bit of action on Mars before we make it too hot, so cool it down a bit. Let's have Mars roughly around the Earth temperature, or the current sort of Earth temperature today. So we want Mars to be sitting around 15, 16-ish sort of degrees, so 40. Okay, so we can roll with that. So where are we at Mars? So for instance, we may see at this point in time, so where's Earth? Where has Mars gone? Mars? There's Deimos. Mars? There's Mars. Okay, so Mars at this point, we could see possible atmosphere starting to rebuild. Obviously, the possible water on the surface. So we'll just have to do that maybe. Let's just see how it works. Obviously, that's going to need to sort itself out. I don't know why there's so much ice on it. But what we can do as well, where's our atmosphere? Maybe Mars would rebuild its atmosphere a bit. Who knows? We don't know what terraforming technology could be like. So what we'll do is we'll make a little more Earth-like. So we'll go 0.7. Maybe we built a bit of Mars's atmosphere up. So hopefully Mars may see a bit of a life before the sun gets too hot, or too bright. So in theory, that would possibly start to sort itself out. Possible oceans colonization on Mars. Who knows? So there you go. Let's just do that. So a bit more water settling on Mars. Let's see how that sorts itself out eventually. So yeah, we'll let that just sit around for a bit. So Mars, yeah, 17. It's still very cold though in the night, or in the darker areas. Minus 44. So the sun, I think we do need to buff the sun a little more. Obviously Venus, 611 now at Venus. We can start to see, yeah, very hostile there. Earth is in the 83 degree mark now. So again, I think we're going to have to hop back to the sun because we don't want to like spend 10 minutes on every little jump we do. So I'm going to boost the sun up to about 3 luminosity now. So let's sit around there. So we can start to see Mars. We could probably start to see Mars have some changes. So let's see how that sorts itself out. I think Earth probably would get close to 100 now, possibly. Venus is still increasing. Earth is hitting that 100-degree mark. So how are we looking on Earth? That's Venus again. Where is Earth? Here we are. Okay. So, yeah, not looking good on there. Future Earth getting very, very hot. Mars is still very cold at the night time. Minus 30, 40. So, yeah, Mars has got quite dramatic sort of temperature change. So, interesting. I wonder if it would it be like that in reality? Who knows? Where is Mars again? I keep losing track of old Mars. There we go. So, how's that sorting itself out? Yeah, it's still taking its time, but yeah, possible colonization could be on Mars. Who knows? So let's keep this going. Remember, it's all speculation, just for a bit of fun. It looks like the ice and stuff is a little glitchy, so what we can do is we can just simply turn all that nonsense off, or turn the snow off anyway. So there we are. Alrighty, so Mars, yep, still very cold though. That's probably why the average temperature is still showing it. We can see Venus 660 and still going. We can see Earth, the coldest point on Earth is 46, so that's pretty much hotter than anything around at the moment. So yeah, not looking good for old Earth there. So all that water vapor building up that greenhouse effect, not looking good. So I think at the next jump we do with the sun, I think what we're going to do now with the sun, we're going to start pressing the double button. So we're going to go ×2. So we can go to 6 luminosities. So the Jupiter area is now starting to reach that. But I think at this point, poor old Mars probably won't be able to support its water anymore. So I think Mars will go back to the way it was. So also, yeah, 60 degrees. I think that's bye-bye for the water, unfortunately. So maybe Mars would start to build up maybe some more atmosphere pressure. Who knows? Obviously, the sun is going to warm it up a lot more. How's Earth doing? 180 degrees on Earth. So I think this is the point where Earth is going to transform to its next pre-built stage that I set up for it. So, for instance, Earth, very, very, the surface is almost hidden. It's obviously very similar to sort of Venus appearance. But now I'm taking it to the next stage. So if I search Earth once more and replace it with this object here. Okay, so that's replaced it. So now if we look at Earth, where are we? So here you go. Atmosphere completely covered it up. We can probably start to see the surface underneath. I've sort of set it up to appear like a Venus sort of look. The surface may have started to melt. Water's all gone. No constants identifiable anymore. Because obviously in the future the constants would have changed anyway. So I've just got a pre-built sort of one there. Obviously I'm not saying the Earth's going to look like that. It's just a little bit of fun there. So how are we doing? Interface. Obviously it's going to be quite similar to Venus interface now. So play. And there you go. So it'll have a little different. Also, we need to add our. Well, I think we had it. I think at this point as well. That greenhouse effect that will be starting to become a global greenhouse effect. It's obviously going to take action. So it's at 49. I mean, it's not going to be as crazy as Venus. So I'll put it around 30. I think 30 is a fair, maybe fair. I'm not really sure because obviously it hasn't happened yet. We want to add the temperature one. No, I don't want composition. I want temperature. Thank you. So, can we add that on? No? I guess I have to press the button for all of them again. So, there we go. Right. So, let's just go ahead and just remove all that. We obviously want the temperature one. So, let's do that. Get rid of all those ones. Okay, so Venus, 780. So, poor old Venus. Oh my gosh, what is going on here? Right. That does look cool the way that is working, though. Let's just go back to... there we go. Okay. So what's going on over here? Yeah, that's not looking too good. You see, the clouds are starting to fade out. The surface is now visible. It's very, very violently hot here. So, yeah, not looking good for poor old Venus now. That's in a real state. But one thing we haven't paid attention to, how's Mercury doing at this point? 380, not really too much. 400 degrees, because remember, Mercury hasn't got that atmosphere of Venus. But we can start to see even Mercury starting to get pretty hot. So, surface. Can we look at the temperature? So we'll add Mercury on there now. So 713 on that hottest point. So yeah, it's not as hot as Venus, but Mercury is still in competition for that hot pot or that hot spot. So there we are. Remember, it's obviously closer to the sun as well. So yeah, not looking good for poor old Mercury. But now we can start to see the outer solar system, Jupiter. It's below -100, but again, Europa is what we were going to be looking at. I don't know where Io's disappeared off to. It's probably because we're running the simulation too fast. So Europa, -136. Still no changes there. 135. So that's still going to need a lot more time to sort itself out. But yeah, what happened to Io, I wonder? Is Io still in here? Did it crash into Jupiter? Where'd it go? Io. How did Io get over there? Deary me. Let's just go ahead and get rid of that then. because we don't need to pay attention to Io, so that's fine. Right, so... Alright, let's let it run again. So, inner solar system, completely uninhabitable now. So, we can now really boost the sun up. So, what we're going to do is we're going to go from 6. I'm thinking something like this. We're going to get the blue zone out to Saturn's orbit now. So, something like that. So, we can see it's now 4.5 radius of sun. It's almost at 10 luminosity now. So, not looking good at all. So it's really starting to kick in now. So obviously Mercury 800 plus, Earth 120. I think we're going to need to buff that up a bit. Venus 880, Mars 130 at Mars as well, right? How's the moon doing as well? I'm paying attention. 148 at the moon, okay. Earth though, yeah, I think at this point the greenhouse effect is going to be full on like Venus now. So I think what we need to do, that's going to go up to roughly 120 now. We'll have it just under Venus's sort of level there. But yeah, Earth is fully transformed to Venus-like conditions now. I guess we can boost it to 400 to see if it can handle that. I don't know, but yeah, we'll let that just do its thing. Obviously, the sun appearing a lot bigger now because it's 4 times as large. So now let's head. We're going to start focusing on Jupiter itself and its moons. So again, Europa is what we are going to want to be paying attention to now. So, it's gonna, come on, Europa, you know, you want to sort yourself out. Come on, 100. It's taking its time. Let's go to minus 50. Let's see if it can support minus 50 yet. But it's starting to evaporate. No atmosphere here. So, Europa starting to sort of disintegrate out. But now we can start paying attention to Saturn's system as well. So, where's good old Titan at? Titan, where are you? There you are. Should be this one. 130. So, yeah, we're nowhere near the Titan sort of boundary yet, because it's still on the... further out area. One thing I want to pay attention to is just the outer planets in general, because I want to just see how bright are these planets now, because obviously the sun's brighter. Neptune in theory would receive more light. Obviously I want to check. Remember the 5th gas giant, planet 9, is this receiving any sunlight yet? Maybe not. No, it's still completely dark here, so no sunlight has reached that yet, even though the sun is a lot brighter now. So, how are we doing? Let's actually just go onto chart mode and just see how the solar system is looking at the moment. So, obviously, gas giants are all fine. But if we look in the inner solar system, Venus, really not looking good anymore. Earth is obviously now the stage of Venus it will kind of be at the moment today. Mars, 97 degrees. Where's poor old Mercury as well? Starting to get a little more hot. Not looking good there either. We can see Europa. Yeah, Europa is smoking up now. Not good at all. So, losing material as the sun starts to warm it up. So, click play. I do want to see Europa be a full-on water world. I think that'd be really cool. So again, the sun. I think what we're gonna do now. I don't want to times 2, but I want to go to around 15. Let's just go boost straight to 15 luminosity of sun. So that's a big boost. We're past the orbit of Saturn now on the area, so we can see Europa's sitting happily in that green area now. So this should, in theory, I mean, we may have to give it a little bit of assistance, but I think that should start to be warming up, I think. I mean, if it's 0 degrees, yeah, it won't handle 0 yet. Mars, 168. Venus is now in the thousands. Mercury's hitting the thousands as well. So, if we just have a little look down here, not looking good at all. Where's Venus? Yeah, that's really not looking good either. What about Earth? How's Earth doing? 165. Yes, I do think that should be a lot hotter than it is, I have to say. Let's turn off that lock that's on it as well, okay? So, let's, again, keep boosting the sun up. So... about 20, 23. So even more boost. Luminosity's getting brighter. Come on, I want to see the Jupiter moon start to warm up at this point. Come on. We are in that green area. They should, in theory, be doing it. How's Ganymede? We haven't altered them yet. So minus 70, minus 49 on Callisto. But they should, in theory, be warming up now. Let's just put them straight to 0 degrees. And let's just see where they can, where they would sort of go to at this point. So, again, Europa as well. We already did that with that. That's still getting colder. How's Ganymede and Callisto doing? So... let's just lock onto Callisto. See, they're still getting colder, so we do need to buff the sun until we start seeing Callisto and all the other ones start to warm up. So, again, let's really boost it now. So, yeah, we want to be going to that super sort of... it's almost at 10 radius of sun now, so the sun is really sort of entering the red giant sort of phase now. The surface temperature could start to be cooling down as well as it gets like this. So, how are we looking on Jupiter? Jupiter's almost in positive temperatures now. Europa... I really think that should have been warmed up by now. Callisto, yep, they're taking their time. Okay, so we'll have a little look on that. Let's stay on Europa for the time being, though. I really think that should be 0 degrees by now. That should be warming up. But what we can, I guess we can have a little play of it. It's just No, is the water's not going to melt. I do want to... Where's that melt button? I do want to... How are we looking? Yeah, there you go. So I think Europa... Obviously, it contains a lot of water. I think Europa would, in theory, look like something like this at this point. Something like that, maybe. So it's losing its material, though, 'cause it's got no atmosphere on it properly. So that's not really... Not looking good at the moment. So, yeah, Europa... Just a rough estimate, a little bit of a play around with it. But, yeah, there you go. So that's still getting cold. Oh, dearie me. That wasn't meant to happen. So I guess you could say Europa eventually vaporizes at this point. Who knows? What's this object over here? That's Dione. Why is Saturn's moon Dione over here? I think stuff is starting to get thrown out as we're running the simulation really quickly. So we don't care about that. As long as it's not Titan. Because that's the next sort of destination we want to be looking at. So, okay, so Ganymede and Callisto are still there. Io and Europa in theory. Or Europa... Maybe that would dissolve completely. But yeah, we can obviously add it. Quickly just add it back in manually. Because that shouldn't have happened. So, obviously I'm just estimating where their orbits are. So these aren't accurate. But we're just going to place them in there. Let it sort itself out. Slow it down a bit. Okay, so those orbits are getting chained pretty crazy. I don't think we need to look at Venus anymore. Because it's getting too hot. Mars. We know the inner solar system has just completely had it at this point. So we'll leave them there. Green zone also getting a lot further out. But again, just one more look at the inner planets for the time being. So Mercury, not looking good there. Venus, again, that's just ridiculously hot now. Earth, I still think that should be hotter than it is. I think it should be, not like that yet, but I think it should be roughly in the 500s now. Mars, 220, it's even Mars, 228 on Mars. Wowee, right. So, Saturn. Where's old Titan at? Titan? Minus 54 on Titan. It's still, Titan's warming up. Oh, yes. Minus 20. Let's give it a little boost. No, it still can't get any warmer than minus 20. So, again, I think the sun is going to start needing that buff. So, I believe once the sun gets to around 100 luminosity, I think that's where it's really going to start sort of increasing as that red giant phase starts. So, we're going to boost it to 79 now. That's really crazy. So at this point, even the Jupiter stuff would start being just too hot, I reckon. So how are we looking in here? So where is Europa, for instance? Minus 20, still smoking up. Yeah, I think all of these guys have had it. Yeah, now Europa's warming up. So in theory, now we can actually press the melt button. So there you go. So that's melted. Io, for instance, as well. 14 degrees there. Oh, well, that zone disappeared. Europa, obviously we did that one. Ganymede, 34 degrees at Ganymede. Callisto, 68 at Callisto, and still going. So yeah, Jupiter's moons, they've had it. Completely had it at this point. And the sun is currently 79.4 luminosity. Alright, where are we at? Why is Mimas out here? Let's get rid of that. That shouldn't be there. Any moons that are broken away, we'll just leave them be. So, right. Titan. This is where our focus is now. So we are going to keep an eye on that. Because this is obviously the next object out, in theory, going for that sort of habitable planet, so, or habitable moon. So 3 degrees, so Titan is starting to do it. We can see more orbits are just breaking away because we're running this simulation so quickly. So we can see let's just go ahead and get rid of all these unnecessary orbits because it just adds extra lag to the game, so we don't want that. So, okay, let's let that just keep running. Look at the moon's orbit. I didn't notice that, but it looks like the moon's orbit has slightly been altered. And that, in theory, makes sense because the moon doesn't have the gravity to really compete with Earth, and even the moon. Like I said earlier, the moon is starting to just be a hot rock like Mercury is at this point, and it is losing material as well. So yeah, inner solar system has just had it. But yeah, Titan, that's where we want to be looking. So possible colonized Titan at this point. So yeah, 79 luminosity of sun. We can go ahead and just get rid of the other Saturn's moons because they're not necessary at the moment. So we don't need any of that. Get rid of that one. We are just focusing on Titan now. That's all we need around here. So there we are. So Titan's still getting some of the areas are getting warmer. Other areas are still cold. How's Uranus doing at this point? I mean, 130, that's warming up. Neptune is still out of the zone, but I'm guessing the sunlight should be a lot brighter here now. Yeah, it's definitely looking brighter. Let's go ahead and see the fifth gas giant. Is any light getting out to reach it? Yes, it is. The Planet 9 is starting to receive a bit of light from the sun at this distance. So, good stuff there. So, back to the inner areas now. So, even the start of the outer solar system area, Jupiter is now in the bad areas. Titan, I think we're going to have to start to increase it more. But at this point as well, once the sun's getting this sort of bright, I think its radius is going to really, really start pushing it now as it really starts draining its hydrogen fuel. So what we're going to do is Venus is just not looking good. But what we're going to do is we're going to have to start messing with the radius button as well. But let's go to we'll go to 100 before we really start to mess it around. So 100. Not 1,000, but a minute, no. Right, so 100, click play. So that's all sitting comfortably. So what I'm going to do is I'm going to throw a save in at this point. So in case anything goes wrong with messing with the sun stats, we're going to get a save in just in case anything goes completely crazy. So let's just quickly check we've got that saved. Okay, so future free. Okay, so that is saved. Excellent. Right, play. So let's see where stuff now focuses. So Titan, still very cold in the dark areas of Titan. So that's warming up though. You can see Titan. Yes, so 100 luminosity of sun. Possibly where Titan becomes the next sweet haven for humanity if we're still around at this point. So yeah, if we look underneath, maybe, I mean, I know Titan doesn't even have a proper sort of a surface texture, but in theory, maybe we get water on it, maybe we don't, but again, it's just for a bit of fun. So yeah, Titan doesn't have any surface grids, so it's all flat, the surface on this. As soon as I add a bit of water, the whole thing just floods up. So I guess something like that. I mean, yeah, you can't really play around with Titan too much because it has no surface layer. But yeah, there's Titan. So again, even Titan though, 22 starts to get a little too warm at Titan now. So not looking good. How's the inner solar system? I mean, we've already seen it. And actually Jupiter. How is Jupiter itself doing? Minus 19? Okay, that's interesting. The moons of Jupiter. How are we looking here? So Europa, that would in theory just dissolve completely at this point. It's losing mass, I'm guessing. 18 degrees there. Those upper moons are hot. How's the inner solar system? So, but yeah, Earth is now in the 400s. And also, look how big the sun is now. Oh, dearie me. So, yeah, getting pretty big. Oh, wow, right. So, where are I? Mercury and Venus. Have a quick look at those guys as well. 903. I'm guessing Venus is at 2,000 almost. Yep, crazy. Mars, 403. Okay, play. Let's keep it going. So, right. But I think we're at the point where the sun is going to start not just getting a lot brighter, but I think that luminosity, as the sun starts to just get really, really, really big now, I think it's going to start to engulf the inner planet areas. So we're going to do this. But also one thing, as the sun gets bigger, in theory, the system will expand as well. So we'll have to manually do that because it's going to push the outer sort of planets' orbits outwards. So for instance, Jupiter, Saturn, Uranus and Neptune especially, their orbits in theory may actually be pushed out and increase. So we're going to have to sort of, yeah, we're going to have to really experiment with the game and just see how this is going to work. So let's get to this. So luminosity, so yeah, radius is what I want to really now mess with. So just looking at some notes I took down. So once the sun starts to increase in size, its luminosity really spikes. So what we're going to do is we're going to do this. So we see the luminosity is still being altered, but as we make it bigger and bigger, that luminosity is still getting pretty crazy. Titan, for instance, we can get rid of that now because Titan's starting to get just too hot now. So there we go, but we're just going to slowly let it do its thing. And we can see the temperature is decreasing as it gets larger. So keep that in mind as well, because that is supposed to, in theory, happen. But as the sun gets larger and larger, that luminosity should spike up to around 1,000. So let's just keep it going. Obviously, Mercury, not looking good at all. So, for instance, yeah, sun, very, very crazy. Mercury is just going to, in theory, be dissolved or just be engulfed by the sun as it increases. We'll have a quick pause as well just to see how everyone else is doing. So, Earth, yeah, not looking good there at all now. The surface underneath is just completely had it. No recognition of the present-day Earth anymore. Venus, again, boiling hot. Mars, how are we doing at Mars? I mean, in theory, Mars as well. Yep, not looking good for any of these guys. So, right, let's keep it going on the radius department. So let's keep it going. So this, in theory, should go to around 0.4-ish a year. We can see, for instance, Mercury is on its final last legs. It is going to be pulled in to the sun now. So that is not looking good. So, yeah, that's just going to completely fall in. That orbit will just disappear. So we can see Mercury. Is it going to go in the sun? I mean, that is it in the sun or is it just on the edge? God, that is close. But yeah, that's had it. That has completely had it. So all we need to do is press the sun one more time and Mercury will be just completely annihilated. So play, but yeah, Mercury right on the last legs of its existence now. Where are we? So radius. So let's just keep it going. Obviously Mercury has had it. That is just getting engulfed. And then Venus, obviously the next customer here. So again, getting a lot larger, but it should go to around 0.6, 0.7-ish AU. So apparently it's meant to do something like this. So it engulfs Mercury and Venus. But then apparently it's once its hydrogen runs out. Now, I'm not exactly sure how this works. I haven't looked into it enough. But once the sun hits a size where it runs out of hydrogen, apparently it's meant to go smaller again. But at this point, what we're going to do as well, we're going to use the expand system button. We're going to press it once, if I can remember how to access it. Simulation, there we go. So we need to press expand system once. So where are we? Expand, where is that button? It's hidden somewhere. View tools, there we go. Expand. See, as the sun gets bigger, it's pushing some of those orbits out. So, expand, there we go. Press it once. So all I'm going to do, press once. The moons at this point, we won't be able to simulate anymore because when you expand the system, the moons get left behind. So, for instance, Io, obviously Europa, Ganymede, Callisto, they just need to be deleted because we can't simulate those. Titan, for instance, as well, wherever that is now. So Titan needs to be deleted. So, yeah, because we've expanded the system out. So, where are we looking? So, I think Earth should, in theory, be around 1.3 AU now. So, let's have a quick look. So, this needs to be around 1.3. So, okay, so I want to expand it again. So, tools. I've never, ever got used to this. So, expand. Okay, so 1.2, a little bit more. Okay, roughly there. I want to leave it roughly there. So Earth is apparently going to get around what it's going to be pushed about. Remember, it's all speculation. This is just notes I've taken from research. So, how are we looking? So, systems expanded. Neptune should be around 40-ish AU now. 40, 50 AU. Yep, 39.4. Yep, that's cool. That works. Uranus. This should roughly be where Neptune... Yeah, okay, so it's 23. Saturn. Yep, so again, being pushed out. Jupiter as well. You're going to be pushed out. Luminosity of the Sun. Obviously, pretty huge. But before the sun turns into what I believe it's called a red clump, once the red giant phase ends. So, what's happened? Oh, that's not even Planet 9. I was trying to click on Planet 9, not whatever that is. Planet 9. I think there's just some particles. We'll just delete any particles in here. So, Planet 9, in theory, should be getting some, decent sunlight at this point. So, sun, obviously, very large. So, let's, can we select the sun, please? Okay. So... once the sun's hydrogen runs out, as far as I understand it, this is where it would have what's called a helium flash, where it suddenly pops down again as it starts to burn a helium supply of fuel instead. So, sun, again, buffs up, gets super, super large, pushes some of the orbits out, but then, in theory, it's supposed to just sort of pop down to a very small size again. So, it goes back down to around, I think it's 11-ish, 10, 11-ish sun, so something like that. And the luminosity as well, this would in theory cool down again. So, why is Mercury still here? Get out of here, you were engulfed. Venus as well, you were engulfed. Maybe I didn't run the simulation, but yeah, there we go. So this is what the system would look like now. So Mercury and Venus gone. I'm not sure the asteroid belt object would still be here at this point. Mars, obviously not looking hot, but again, so the sun is now a red clump again. The temperature, I'm not sure, would stay like that. But it would... still start to increase and decrease. So something like this is supposed to happen. So I believe it's going to go up and then down, up, down, and something like this. So then it gets bigger, smaller, bigger, smaller. As it's using the helium, it constantly changes as far as I understand it. So stuff like this. And then until it eventually gets to the point where... I think I actually just broke the orbit of Earth. But eventually it gets to the point where it just pops into nothingness, like we've just done there. So... again, the future of Earth, in theory, is uncertain, but now the solar system is bust. Obviously, the white dwarf star should be here. So, I don't know where it's gone. Obviously, we'll have to rerun that, but there's just a rough sort of example. So, once the sun enters the red clump phase, after the red giant sort of pops down smaller again, it starts burning its helium fuel, and then the size goes up, down. The luminosity, obviously, would change up, down as well. But, yeah, eventually it just keeps... burning that helium, and once that helium pops, the whole star will just sort of break off into billions of atoms, and then eventually will just turn to a white dwarf. So that's the way I understand it, but I'm not too knowledgeable on this red giant, red clump phase where it starts burning the helium. But that, as I understand it, I think I've simplified it fairly well there, but you guys can be the judges of that in the comments. But let's go ahead and just return to the future, because I just need to spawn in the white dwarf star. But I think the sun actually popped quite... honestly, I was quite pleased with the sun just popping like that, because in theory that's what it's supposed to do. So again, let's pretend this is the red... oh dearie me, what has just happened there? All those moons have just been popped out. But again, what we're going to need to do is just delete all of those guys. So Ganymede, Titan obviously needs to disappear. Callisto, thank you. Okay, so again, we're going to need to expand the system till the orbits are further out. So let's go ahead and... I always forget where that button is. Right, so auto orbit, and I don't want that to expand out. So how are we looking now? So Earth should be around 1.3, and I believe, yeah, stuff like Uranus, Neptune, these guys are just going to be pushed out stupidly far as well. So I believe Neptune is meant to go to around 45-ish, so even further out for Neptune. Uranus, I think, is meant to be around, sort of, again, it should be a lot bigger than that, so something like this. And then obviously Saturn. So basically Saturn would now be in where Uranus would have started off in the present day. So again, we're going to push it around to 17. Old Jupiter now goes to around 9-ish AU. So this expands out. So yeah, as the sun pops and gets bigger and smaller, that pushes the orbits out for some of them. So we get something like this. The inner solar system is obviously affected less, as there's sort of less distance to sort of travel as it boosts out. So it's the outer solar system that really gets changed here. Let's get rid of all those. So again, this would be right after the sun popped Mercury and Venus and then got smaller. So let's go ahead and just quickly... Yep, go ahead and save it again, because I don't want to have to keep resetting it every time something goes a little wrong. So there we go, future 4. So this is now back to the helium burning sun. So let's do that. Obviously, this would still be getting bigger and smaller, so let's actually just have a little run of it. So again, it'd be doing stuff like this. It gets bigger, smaller, bigger, smaller. So stuff like that. So it just keeps doing this until eventually it runs out of helium completely. And then it would eventually just turn to a white dwarf. So we should actually be able to manually do it. So just bits like this. And then this would push out the orbits. Obviously, I can't simulate it all at the same time. Obviously, the fate of Earth is uncertain. Earth could be pushed out. It could be engulfed. But for the purpose of this video, I think Earth and Mars, I think the whole inner solar system, in theory, once the sun pops and all that, it just releases all of its material, I think the asteroid belt area, I think that would all go. So it would just, we'd be left with just the outer solar system area. So now what we're going to do is the sun, it would obviously pop super large. I don't think it would go to 1.4, I have to say, but then it would just go. Also, it would lose its mass as well. Don't forget, we haven't actually altered that yet, but the sun would lose its mass until we eventually get a white dwarf. So what I'm going to do here is, actually, I'm not sure. We'll have to, actually, you know what we'll do is we'll just replace it with a white dwarf star. I think that'd be the easier thing. So the sun eventually would pop. What was a white dwarf? I think it's Sirius B is a white dwarf, isn't it? Let's go ahead and spawn that in. So there we go. So Sirius B, yeah, roughly the size of Earth. Obviously, there you go. Click play. Sun bursts, destroys the inner solar system, pops all the way down to white dwarf. It releases all of its other material, and eventually you get this. So white dwarf, Sirius B. I mean, obviously this needs to be named Sun now. So that's all that's left of the sun. So little white speck. Obviously nothing out there, and then that's in theory where we're left. I think the orbits of Saturn may have gone a little funny, but yeah. Not sure about the fate of the dwarf planets, I have to say. I haven't really seen anything about what would happen to these guys. But the inner solar system, as far as I would assume and understand it, no more inner solar system. So Jupiter would be the first planet left. And then, obviously, all that's left to really run now is just the aging of the white dwarf star until eventually it just cools down into a black dwarf. So, obviously, we just have to hold this button. We're travelling just millions of years. And also one thing I'd note, I didn't mention it, but obviously this isn't really involved in the solar system, but when the sun turns to a red giant, in theory the galaxy collision would have happened, so that background shouldn't be looking like that anymore, to be honest. So, there we go, but white dwarf just eventually cools all the way down to a black dwarf until you eventually get this. So that's all cooled down, so nothing left there, no more luminosity. Luminosity is just, yeah, completely gone until black dwarf. And then that would eventually just completely freeze cold. So now we're at the point where either the gas giant orbits, the planets would break away. They would leave the solar system and just be rogue planets. Or maybe they would smash into the sun as their orbits decay. So for instance, we could have a little fun with Jupiter and the sun here. And obviously that collision could cause an explosion. I mean, I don't know if it would simulate it. But what we're going to do is, let's pretend Jupiter's orbit decays. So we're just going to lower it down until eventually the sun and Jupiter have a collision, because Jupiter in theory could possibly be the first one. So let's just for instance say Jupiter, its orbit decays, it gets too close to the what's left of the sun until eventually it's just going to crash into it. So we can see, I think the Rouge limit may actually be tearing it up. I'm not sure what's going on there, but we're just going to keep lowering it down until eventually they're just going to make contact, where the rogue Jupiter at this point its orbit is decayed all the way to the center of what's left of the solar system until eventually the orbit decays and they collide. So let's just see. I'm not exactly sure that's supposed to happen. I think we were supposed to have a little bit of an explode. Oh, it's because I wasn't playing the simulation. That's quite a silly move on my part. So let's just go ahead and pull them outside quickly. But we're going to slow it down. Click play. But again, Rouge limit of the remaining sun would probably... See, I'm not sure that's exactly right. But maybe it would cause an explosion. So, for instance, just for a bit of fun, we'll blow it up. So they collide together. Where are we? Explode. Kaboom. So, no more sun left. And then, obviously, all of the other planets, eventually, they would either just crash into the remains of that, or they would just break away into the depths of space. So, for instance, I'm not going to call that a supernova, because I don't think it would have been, but it would have some sort of explosion, I reckon. I mean, who knows? It's all speculation, really. Remember what I've said in this video. It's all just a bit of fun, no facts. It's all speculation, just theories, speculation, possible scenarios. And, yeah, that's it. End of the solar system. That's in theory all you can... That's what you leave it on. I mean... That maybe more of the orbits would have decayed, maybe they wouldn't, maybe they were just broken away and the black dwarf sun would have just sat there for eternity. Who knows, but that's the way I'm going to tell the story here. So I hope you guys have enjoyed today's video. So yeah, we started off with the sun getting brighter, more luminous, gets larger. The Earth obviously lost its habitability, so wasn't good there. Obviously Mars was habitable for a little bit, that got too hot, so the inner solar system all turned uninhabitable. We can sort of actually look back at the stages actually, so because I had all these saves. So we started off with where we had done a few of the future events that changed the solar system. Then we moved on to save 2. This is where the inner solar system was starting to get a little more hotter. So if we look here, obviously the luminosity of the sun was getting worse. The Earth, for instance, was all getting warmer. And obviously we moved on to the next stage, so Future 3. Hang on, did I already click Future 3? Oh, no, so yeah, Future 3. So obviously this is where the orbits were all just not looking good anymore. It looks like Jupiter and all the moons just break away now whenever we play. But yeah, all these guys, obviously solar system got uninhabitable. And then the next step was where we were on the helium burning sun. So the sun pops up, turns into a red giant, then all of it runs out of its hydrogen, it starts burning helium, so it gets a little smaller, and then we go to the stage where the helium burning sun just expands and decreases in size like that. So bits like that, not sure it was meant to do that, but again that would just pop into the white dwarf like we just simulated, and then the orbits would either just decay or would crash into the remains of the sun. So yeah, there's our sort of story. Obviously, if I missed anything, if there's anything you think I should have included, stuff I shouldn't have included, let me know down below in the comments, because obviously everyone's opinion, let me know what you think, really. But yeah, that's just the sort of way I'd interpret some of the stuff I researched. So yeah, I really hope you enjoyed this video, guys. And yeah, if you did, make sure to hit that like button, subscribe for more. And yeah, the solar system is no more. But yeah, subscribe for more, leave a like. Let's see if we can go for 60 likes on today's video as the solar system just breaks off forever into absolute nothingness, into the Milky Way. So there you go. And actually one thing we can do just to end it off, obviously the galaxies would be collided at this point, but let's just go ahead and spawn in. We'll go into just a new simulation. So, and we're going to spawn in a galaxy. So it's not often we visit the galaxies, but yeah, before we finish off, I just want to do this. So where's the background? We're just going to put that to just stars, and then I'm going to spawn in a good old galaxy here. So where are we? So galaxies. Yeah, it's very rare I do this. So this would be Milkomeda at this point, so Milky Way, Andromeda, they would have collided. So we'll just use the Andromeda Galaxy for an example here. So pretend they've both collided. This is now what the solar system would sit in. So what we're going to do here is we're going to put the sun. So, oh no, also we need to go to sun. Okay, so we're just going to spawn the sun somewhere in there. Okay, that's fine. And then we're going to add the planets to the sun. If I can select the sun, of course. Can I? Sun? Please? Can I select it? There you go. Okay, so sun. I'm going to add planets to star. Okay, so now we should have the solar system planets in here. So what I'm going to simply do is delete the sun. Yep, can I delete the sun? Delete the sun. So click play. Obviously, we're going to need to speed it up really far, but let's just see what... Obviously, the sun would disappear. Let's pretend the... obviously, the inner planets aren't what we're interested in. It's the outer planets. So let's just see where the outer planets there would just break away into the galaxy. And, yeah, the solar system planets would just orbit the galaxy as rogue planets, really. So there you go. So they'd all just orbit. Also, you can see they've all split up as different distances. So obviously Mercury, Venus, Earth, and Mars, they wouldn't be there. But the outer planets, if they break away and they don't crash into the sun with decaying orbits, if they just leave the solar system area forever, they just orbit the galaxy. So yeah, pretty cool stuff there. But yeah, that all said and done, guys, again, a massive thank you for watching today's video. I really hope you enjoyed it. Again, anything I missed, should have included, let me know down below. Anything I got wrong, anything I got right. If you think, well, we can't say anything's right yet because it's always all future speculation. But anything you think I got maybe inaccurate, let me know. Obviously, if you want to explain a few things as well, because obviously I'm still a little, the red giant, red clump phase, once it starts burning helium, that is a little, that's quite confusing to understand. I have to say some of it. And I'm pretty knowledgeable of my star stuff, but yeah, that is, it's quite confusing when I'm just reading off a few little notes I made. So obviously I haven't read you an entire sort of description on it. But yeah, that's just a rough example. I mean, it's just a bit of a game. It's a sandbox game. That's what it's for. Just have a little fun experiment. So yeah, really hope you enjoyed it, guys. But enough of me rambling on. Again, massive thank you for watching today's video, guys. And yeah, I will see you in the next video. So make sure you guys all have a great day. Stay safe out there. And I will see you in the next video. Goodbye.